In this video we focus on a geometry problem related to a circle. Imagine that you have a circle like that, and this circle has a radius r. We are trying to fit smaller circles, finite smaller circles inside the circle. Let's say this one is r1, this one is r2, r3, r4, etc. And we want to derive an inequality. The area of the big circle is pi times r squared, and the area of the smaller ones pi times r1 little r1 squared, pi times rn squared. In order for the circles to fit in this bigger circle, the area of the big circle should be bigger or equal to the sum of the other circles, of the areas of other circles. This is pi r squared, and this is pi r1 squared plus pi r2 squared plus pi rn squared. I can take pi to be the common factor, r1 squared plus r2 squared plus rn squared. I can simplify pi, and I have that r squared should be greater or equal than the sum of the radiuses of the different circles. I take the square root and I get this inequality. I can write it as r little l2 norm. Now let's assume that r1 equals r2 equals r3 equals rn equals r. I go back to this one and I have that r is greater than r squared plus r squared plus r squared. So I have r greater or equal than n times r squared. Here is a squared, sorry. And I take the square root on both sides of the inequality, and the condition is that r should be greater or equal than the square root of n times r. This is my first inequality, and this is the second inequality as a consequence of choosing same radius for the smaller circles. So the radius should be greater or equal than this multiple here, the square root of n, where n is the number of circles, times the radius that each circle has.